Hello everyone. I'm going to talk a little bit about the interior angles of different polygons, and then after that I'm going to do a couple examples. So first thing here, I have a couple different polygons drawn, each one with one more side than the last one. So we have a triangle, quadrilateral, pentagon, and a hexagon here. The interior angles are the angles that are each on the inside of all of these polygons. Alright, and I want to come up with a shortcut to determine the measure, the sum of the measures of all the inside angles. If I add up all the angles on the inside, what does that equal? We already know for a triangle that the sum is 180. So the triangle sum theorem tells us that no matter the triangle, if we add up the interior angles, we get 180. So I'm going to say that just so we have something to reference to, I'm going to use n to represent the number of sides. So when we have 3 sides, the sum is 180. Now if I add in another side, I have a quadrilateral here, but what we can do is, since I already know the sum of a triangle is 180, if I draw in a diagonal, okay, so a diagonal goes from a vertex to a non-adjacent vertex. I split this quadrilateral up into 2 triangles. So when n equals 4, my sum, I have 2 triangles. Each one of those triangles has 180 degrees. So that means our sum is 360. And now we can continue that pattern. So with the pentagon, so here n is equal to 5. I'm going to split this up into triangles. So from one of my vertices, we'll draw in a couple diagonals here. So here, my pentagon gets split up into 3 triangles. So the sum is equal to 3 times 180. And if we do that multiplication, we end up with 540 degrees. And by now you can probably already see the pattern. It is increasing by 180 every time. So for our hexagon, so n is equal to 6. If we draw in the diagonals from one of these vertices, we can split the hexagon up into 4 triangles. So 4 times 180, we get a total of 720. Okay, so now let's try and generalize this. So I want to do this for n sides. Okay, so then this formula will work for any polygon as long as I know the number of sides that it has. So if I have 3 sides, I get 1 triangle. If I have 4 sides, we end up with 2 triangles. 5 sides, we get 3 triangles. 6 sides, we get 4 triangles. So if we notice the pattern here, depending on the number of sides we have, I end up with 2 less than that triangles. So if I have n sides, I can split that up into n minus 2 triangles. The reason that happens is because here we have 5 vertices, for example. I can't draw in a diagonal to these 2 adjacent vertices. Over here in this hexagon, same idea. I can't draw a diagonal to these 2 adjacent ones. So that means we have 2 less than the number of sides. That gives us the number of triangles. So n minus 2, that gives us the number of triangles. Each one of those has a sum of 180. So this gives us a nice shortcut to find the sum of the interior angles. So for example, let's think about an octagon. So an octagon has 8 sides. So that means n is 8. So if I want to find the sum of the interior angles, we'll do 8 minus 2. and then we'll multiply that by 180. So 8 minus 2 is 6. The 6 represents the number of triangles that we can draw. We'll multiply that by 180. And we end up with a total sum of 1,080 degrees. Okay. Now, this little formula, this can be used to go backwards as well. So finish up with this example. It says the sum of the measures of the interior angles of a polygon is 3,240. And then we want to know how many sides it has. So the formula we just justified, we know that the sum is equal to n minus 2 times 180, where n is the number of sides. So we want to solve for that. We are given the sum, so we'll plug this in. So 3,240. So that's kind of our answer, but now we're going backwards. And then we'll solve for n. I could distribute here, but instead I'm going to divide both sides by 180. This simplifies to 1. 3,240 divided by 180, we end up with 18. Okay, so that simplifies. We're left with n minus 2. And we'll add 2 to both sides. So we end up with n is equal to 20. So this is a 20-sided polygon. So there we go. So we have a nice little shortcut now to find the sum of the interior angles. N minus 2 times 180. N minus 2, this represents how many triangles we can split up the polygon into. Each one of those has 180 degrees. And altogether, that gives us the total.